The overall goal of the following experiment is to prepare a novel support material with improved performance in the selective extraction of phosphopeptides. This is achieved by proper preparation of a porous polymer capillary monolith with suitable functional groups. First, a metal species is immobilized on the functional groups of a polymer monolith, making the support selective to the extraction of phosphopeptides. Next, step-by-step growth of multiple layers of the metal organic framework is performed in order to increase the amount of metal sites, thus increasing the selectivity for phosphopeptides. The results show improved selectivity for the extraction of phosphopeptides from protein digests based on matrix-assisted laser desorption ionization time of flight mass spectrometry.
The enrichment of phosphopeptides is usually done by metal ion affinity chromatography, which is performed on either conventional silica particles or polymer particles, which are packed into a chromatographic column. Our material combines the advantages of a macroporous polymer monolith, which has good mass transport properties, with the high binding capacity of a metal organic framework. The way we achieve this is by sequentially growing the metal organic framework from the surface of the monolith, so that in the end we have multiple layers of metal ions that are available to interact with the analyte.
Visual demonstration of the polymer monolith preparation and metal organic framework growth are both important because they're very difficult to learn. There are several important steps that one has to pay attention to in order to achieve a monolith with good surface properties and porosity.